All right, you know what? We don't need to do all that. So hello. Let's see. What do we need to do? You saw in the thumbnail, we've got the doodad, the whatchamacallit, the assembly. The gantry is the word. You have my address. You have my address in Taiwan or my address in America? You have my real address or the fake address? Tomatoes. It's over. It's over. I should just end the stream now. Okay, thank you all for watching. Hope you enjoyed my very brief and exciting stream. Yeah, drop the address in the chat. That's a great idea. Anyway, we need to accomplish something today. So, what was it? Oh yeah, did you guys see that I hit 3,000 subscribers? Now that it doesn't say in the bottom right overlay part, I don't know why it doesn't, it's not like, you know, updating, but here, let me refresh it. Yeah, no, it's just cringe like that. Anyway, but on the official YouTube, on the official YouTube channel, TM, we've hit 3,000. Yay. Anyway, that's not paint. This is paint. Okay. We need to do something today. And that something, so if you saw in the thumbnail, I have, what's it called? I've got the big assembly thingy, the thing that I was designing in part 3.5, and it's on the John. And all I need to do now is basically design the other side. So if you saw in the thumbnail, we've got the stepper motor on the one side. The other side is empty. Then we also need to design the finish up the grabber at the bottom. So basically, I need to figure out where do I mount that the switches, the micro switches, and where do I like do all that stuff. So those are the two things we have to do today. So we will call that the idler side. The idler side of the motion, the micro switches. Let me switch mice. This one's the heavy one. Need the light mouse so I can optimally scribble on my screen. We need micro switches. We need, let's see, what else do you need? Grabber. Need to get the grabber done. Oh, hey, look, it says 3,000 now. Cool. 3,000. Wait, what was I talking about? Grabber, right. We need to finish the grabber. And then we need to, oh no. I mean, after that, I think, oh yeah, we should also do redesigned bins. And after we do the bin, we also need a camera mount. But after that, I believe we are actually pretty much done with the actual, like, physical modeling, at least for now. Once we get these things done, we technically can start working on the software. Yay. Or, well, not the software, but we'll have to do the electricals like in Among Us. So, yeah, we can get to the electrical after we finish our CAD. So yeah, okay, great. We got that done and figured out. Next up, I need to figure out where all my folders are so I can figure this out. No, that's fine, that's fine, that's fine. Where's Firefox? Okay, Firefox is right here. Make this smaller, I guess. That's fine. Okay. Let's hop on over to Fusion 360. Boom. So here's the grabber. Now don't forget, we also need a spot for the belt holder. I mean, not the badge holder, this thing. So that we can use it to go up and down. Well, use it not to go up and down, but to you know, reduce the force required to move the thingy up and down. Because remember, the linear rail is heavy. And so we need to you know, do that. Anyway, this is our frame. Basically, our stepper motor is mounted right here. And so we need the idler right here. So, how about we start with the idler because it seems like the easiest part. So let's just create a sketch on this plane. And it should be pretty simple. I mean, we've got it right here. So all we need to do is basically add like a slot for the what's it called? The idler itself, of course. And then we also need a way to tension the belt. So we will just add a little screw to tension it by moving it outwards. I'm not really sure how to explain it, but that's roughly how it will work. So yeah. Now I do also have spring tensioners, so technically we don't need to design tensioning into this. So we might not do tensioning, and we might just use the springs that I have actually, because then I don't need to worry about it. It's easy, and being easy is always better than being difficult, right? So well, you know what? Let's do it the easy way. We're gonna do it the easy way today. So let's get just some simple. Okay. You know what? We don't actually need any of that. All we need is really just... We don't need any of that either. We just need to extrude this by some amount. How does 30 millimeters sound? Maybe not 30. Maybe we do like 20 instead. I don't know. Here, let me... Where's my ruler? Is my ruler? Shoot. Oh wait, I was using, okay. Yeah, I had to clean my air conditioning unit yesterday, so let me go grab that ruler real quick. Okay, chat, I found my ruler. So I was using it to figure out like which, because there's two filters, right? I was like, are they the same length or not? I measured them. And then I put it down, the ruler down. Now, in that room, I have a box, and I use that box as basically a table. Really horrible, but I use the box as a table, right? And so I put it on the box, and apparently it slid down through that like gap on the top of the box somehow. So that's cool. We're gonna do 30 millimeters, it's better. Okay, and then here we are. We need a sketch here. I don't need to go all the way down. Thank you, Fusion 360. Now we need the midpoint of basically these. So like in between here, basically. So, I don't know. Or here's what we can actually do. Whoa, Haunter needs to sleep early? That's incredible. Alright, and then we need a 2-point circle. Yeah, hopefully the mounting of the mount that mounts the mounts will mount mounter here today. How big is this one? This one's 15. That is not big enough. We need this one. We should make it ideally at the very least 20, but I want like 20, 25 because it makes it easier. And since, you know what? Yeah, that's fine. Let's just extrude this in and a mount. Let's see, how far do we need to extrude it in? Oh, please stop. Okay. Now, is this literally the worst possible way to do this? Yes. But do I also... Oh, wait. Hold on. I know how to do this. Extend to object, and then I go over here and I click this. There we go. Wow. Okay. Now... we create another sketch. Stop teleporting me. We need a 5mm hole in the middle for our M5. Whatever. So that's easy enough. I think that's it. Cool. Great. Let's just extrude this further in by like, I don't know, let's just say 10. 10's a good number. Whatever. And then we need a on top, actually, let's get our old sketch back, and then let's go back into the sketch, and let's actually, you know what, no, we're gonna create a new sketch. I don't need to see this. New sketch on top. Stop teleporting me. Oh, I need to go back to my normal mouse, that's why. One's easier to use. Okay, I need a line. Basically, I can't just have it floating, and so I need to have like some sort of support structure. But then to do that, I need to get it in somehow. Wait, but I could just like, you know, just make that bigger. You know what? Yeah, we'll just do that. Let's go back into this one. Let's finish this. Back into here. Get some more lines. Be tangent, yeah, tangent here. Great. And then we go to this extrusion and we can select this as well. There we go. Check that out. Wow. So anyway, where was I? In this sketch, right? Okay, so we actually don't want this line. What we do want is a line. Oh, we also don't need these. These are leftovers from the yeah, that. Okay, here's what we can do. Actually, we can just delete the sketch. We're gonna get out of the sketch, go backwards, delete that. Okay, now we can create our new sketch here. Stop teleporting me. And then let's just, I don't know, I think I just want a line basic. Let's think, because what I need to do, I need to decide on how, like, how do I do this, right? Because I need to be able to put the belt in. Do I need to, like, be able to put the belt in, though? I mean, yes, technically not, but I would like to because it would be good. You know what? We technically don't. So maybe we just don't. That means we can go into here and we can add another one of this. We're gonna make this one be 5.5. And then let's figure out how long this line is. 14. So now I can view that. I don't need that. I need this sketch. Let's just do this, and we can say down. So it's 14. So 4 millimeters, or we could do 5 actually. I believe this thing is, yeah, it's like 9. We can do 5. Okay, that's what we'll do. And so we just slide it in there and rummage around and hopefully get it to like fit normally. I mean, actually, you know what? How about we go into this sketch? This sketch. And let's create another circle. Right here. And then we can cut out like a good chunk of area so that I have the ability to like put it in correctly, you know? Alright, and then we can go back to this extrusion and we don't select those. There we go. That'll make it a little bit easier at the very least. Hide this sketch now. Cool. Now we need another thing, which is an end stop. Basically, we need to figure out how to tell when this thing gets to the end. So let me test on my real life example. It does rub on one of the parts from before, but that's because I have the screws sticking out on the back of this. So if I wanted to fix that, I very well can. Maybe I will just like fix that real quick. Oh yeah, also I found something else out. So here, this one can be 7. We're gonna say 7. 7. Screwed this by minus 0.5, I think we'll do, really. Not that deep. I mean, it can't be that far because this is not that long, we will say. So like the distance between this face and this face, oh wait, hold on, that face and that face is 4.5 millimeters, which is not a very long distance. So there's something we need to do here actually to improve this. So I need to go back here. Where did I add this fillet? That was here. So I need to go to here and I need to extrude this by about 1. That'll help fix something there. And then I also need to extrude these. Well, actually, you know what? Wait, hold on. I want to move this basically entire thing down by 1 centimeter. Of course. Well, you know what? It's probably fine. The only thing is that moving it will make it annoying to like adjust, but it will make the geometry better. Of course, it might not actually be an issue, so I could just completely ignore it, and we don't need to worry about it. So that might be what I do. I'm just gonna ignore it for now. If it becomes an issue in the future, we can fix it. But the glory of doing everything myself means that I'm the only person who it will inconvenience. At least doing the modeling myself. I'm not like, you know, part of some design team or whatever. Anyway, where were we? End stops, right? So we've got this in by about 4 millimeters or so, or 5 millimeters. In here, let me see. Okay, so basically we don't want the end stop to be at the very edge. We want the end stop to be in a little bit more. Also, my headphones hit my microphone, so that's cool. So we can put the end stop up at the top here. You know, let me get my micro switch so that I can look at it and investigate. So there's a, I believe that's M2. I can't really tell though. Yeah, that's M2 screw in there, and I don't have any M2 screws. So I can just use a little bit of filament for now. I can just like, you know, cut some filament and use that as a like peg to keep this micro switch in. But, you know, I should probably get some real filament of it. I mean, not filament, real, whatever it is eventually. But for now, since I am not willing to spend money, or if I did spend money, it would take a few days to arrive. We will simply do it the easy way for now, and then we can do the hard way later. So, we need a micro switch. Luckily for me, wait, is this joined in with that whole thing? Shoot, where did I extrude this? Oh yeah, that is joined. New body. There we go. And now this should be its very own body. It is, right? Okay, great. Okay, so let's get ourselves a thingy. So basically we can either have it go on there or we can have it at the top. I think here is fine. Let's just also with the rubbing thing, it's not that big of a deal. For now I'll just leave it be, and if it becomes an issue in the future then I'll fix it. But like for now, I think it will just rub the problem away. It will just be its own sandpaper basically. And it'll just eventually disappear. Wow. That's really not how you're supposed to do things, but that's okay. I mean, look, I solved it, okay? The problem has been solved right there. It's just, this part takes like 3 hours to print. Oh yeah, another thing that I can improve is the rigidity of this whole assembly, basically. Basically, if I go back to before I chamfered it, like here. What's this? Okay, that's good. What about this? That. Okay, basically if I go to here, and I change this extrusion from being 10 to 15. Then I can go into here, and then I can create my sketch. Some circles. 7, 7, 7, and 7. I can then, it'll be more rigid. The big thing is that it was not very rigid, and so it could wobble a little bit, and that's not good when you're trying to design precision machinery, right? So we will make this go down minus 3. And now it has more, I don't know, rigidity. Sure. So, there we go. Hopefully that didn't break anything. Yeah, it looks good. Oh, it did break something. What happened? Okay. Okay, what is this? Oh, okay. I see. Well, we can just delete this, actually. Shoot. Yeah, let's see what that breaks. And this one can be 10 millimeters, actually. Alright, hopefully it didn't break everything. It did break everything. That's okay, it's not that of a fix. I can just look at what I've got in real life as an example. That can be straight, that's fine. This and that need to be chamfered. Is this fine? I don't know, that looks fine. Let's do that, that's... I mean, it's sharp on my piece, but that's okay. Wait, it's not cut in half. Is this all one body? Yeah. Okay, why is this entire thing one body? That's not what's supposed to happen. Okay, here, now it's back into 2 bodies. So we can hide that. I still need to extrude this. I guess I don't need to extrude it by 10. I just need to not extrude it by 5 later. How complicated. You know what? If we just ignored it? Say it's good enough. We're gonna say it's good enough for now. Alright, we're back to where we were. So let's get the end stop done. I'll put the end stop on the top side, I think, because then it's easier to wire. That's the only reason why. So yeah, we'll put the end stop right at the top. Unless I just put it here on the side, which I could also do. The real question is, which one's easier? You know what? The side's easier. So we'll do it on the side. Let's see here. Create the sketch. Oops, that's not what I wanted to do. Let's create a sketch. Not there. Let's delete that. We don't need that one. We would like a sketch. Right? Well, okay, let's measure this thing. Maybe it's time I buy some calipers. It's 20 millimeters by 10 millimeters. Okay, that's pretty simple. It's a rectangle of about, well, we want it a little bit higher. No, that's not big enough. This big. That's how big it is. And yeah, that's a good spot for it, I'd say. So let's just give it that much space for the we can give it this much space in total for the what's it called? Actually, you know what we need to do? We don't want to have it there anyway. We actually need to have it a little bit further out. So let's see. How far can this thing slide without running into the issue I described earlier? Well, it can go pretty far if you ignore the issue. And it looks like there's about a limit of 5. So we put the end stop here. I think that would be good, because it doesn't really have a reason to go farther than that. So let's have the edge of the end stop go here, I'd say. That's 10 by 20, but we're actually going to make it be 20 by 20 so that we can wire it. So that's going to be where our end stop goes, and then, well, that's just, yeah, we need to design the slot for the end slot now, and end stop. So we can have ourselves a rectangle from here to, I don't know, there. That's probably fine. How many millimeters is that? Yeah, about 5. Then I believe at, okay, so if this is 1, then, okay, at 0.7, there's a 2 millimeter circle. So actually, we can get out of that. We will put our rectangle like so, I think. 23. And then from here, how far down is it? Okay, it's a little bit bigger than, no, that's 0.5, and then like another 0.5, I guess. So they are 0.5 apart from each other. So from the bottom edge at about 0.7, Okay, so this is the reference. This is the reference I'm talking about. So this will be 5 millimeters, 5, and then this one will be 7. That is where the first circle goes. And then it's the same up here. Oh, where did the circle come from? This is 5, and that's 7. And then we get ourselves a couple of circles, make them 2 millimeters. And then for the wires to go through, I will have a gap there. Okay, cool. So this is on that part of the thingy. What we actually want to do is have it start off of out here, I think. And then no, here, let's grab this face. It should just start off of that then. And then distance. Okay, that's not being helpful, is it? Start offset. We'll just use the offset. Wait, hold on. Why is it being really weird? I want to just extrude some parts. We need to grab the entire thing. And then start off of there. And then this is where it will lay. Now it is about 0.6 millimeters thick. And so the amount of space we have from here to here should be at 6. So we can give ourselves 4, and then we can have 1 millimeter of extra space on the other side too. So I think this is fine. Alright, I need to see that sketch again. So I can extrude these parts inwards. And then I'd like to extrude these parts, these specifically, inwards again. So this is 11. So what is 11 minus 6? We're gonna say it's not gonna be 5. We're gonna do another 4. But anyway, that is our amount for the whatchamacallit, the end stop. Theoretically, it should just fit there. And so that's cool. And so it'll just go click, click, and then we're done. In theory, of course, in theory. Great. Next up, we should do the mounting. How are we gonna mount this thing? Via screws. That's right. So let's create a sketch here. So how long is this? This is the line we're going to be doing it off of. And it is 40 millimeters. So basically at 10 millimeters from the bottom, we can have one that's 3.3. And then 10 millimeters from the 10 millimeters from the top, we can have another 3.3. And then we can have the 7 and 7. And then we extrude this and this all the way through. Objects to cut, specifically body 17, we don't want it to cut 18. Okay. Now let's see that sketch again. Now I would like it to go to this object, which is, and then I would like it to offset maybe -7. No, wait, 7. Okay, 5, 7, 10. How about, so I have M3 by like 15 or something. No, I have M3 by 16 and M3 by 20s. So I need to think about how far does the T nut, let's see, So about 6 millimeters. So if I do an offset of 11, then that will be perfect for M3 by 16. Okay, cool. Now let's create another sketch on this thingy. Actually, you know what? We don't need that. We can just, here's what we can do actually. Now we can trim a little bit out of it. That we can both screw the screws in better and see it with the belt. To like make sure it's not like rubbing on anything better. And this also makes it easier to put together, so. Cool, I think we can probably just print this part now. And just see if it works. So I will do that. Let's add some chamfers. And let's print it. Chamfer, 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 chamfer. Okay. And then we can chamfer here, and 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 here especially. These are very important. But I'll do this second. I think this technically doesn't need one, but I'll put it anyway. No, wait. Yeah, no, it'll be fine. 2.5. And then it gets a problem because it's cringe like that. Cool. Where's the problem? Oh, that's why. Equal distance. Let's just delete all of the selections. We want this 2.5, and we can reselect because we have to do that again. Thank you. Add it there because it makes it look cooler. Whoa, where did I go? Here, here's what we can do. Never mind, we can't do this. I just want to isolate this. So now the problem has been solved. Okay, let's try that again, shall we? Get this. Also, I don't know why it defaults to distance and angle. I want equal distance of 2.5. Now we can grab all of our corners again. Boy, what fun. Wow. Okay, now what happens if I grab here? Okay, see, that's the issue. So let's actually grab these inside parts. Wait, no, this is the end stop. That part doesn't matter, actually. I think the end stop would be better without chamfers. This one is the one we want chamfering on. There we go. Now, can I grab that too? Very good. I don't think I actually want to grab that one. Now, what if I grabbed the... What happens then? Okay, that's fine. We can do that. And then this is the wiring channel. We might as well grab that too. If it breaks, so we are not going to grab the wiring channel. The wiring channel will be fine without it. Now, something I did not consider at all when designing this was how am I going to print this thing? Huh. How do you print the thing? Oh, I guess it's not... Not that bad. I mean, should I just use supports? Ugh, I don't like using supports. You can print it on this face and have all this bridge, but like... Yikes. I mean, if I print it on this face, then I'll just need to support that, and it's not that bad, because all of that can be bridged. Or if I print it on... Oops. Upsy daisies. We designed a horrible, horrible part. Oh man. What what a mistake. Shoot. I don't know why I didn't think about it at all. Usually I do think about it. Well, anyway, we can solve this problem by clicking the cancel button and extruding this about that far. Wow, look, it's printable now, guys. Cool. And also, it's a heck of a lot stronger, so I should have just done that from the start. But, anyway. Can I just, like, make these faces together? You don't see why I shouldn't. I can just do that, and then, wow, it's so much better now, isn't it? And then, you know what? On this face, I'm gonna do something. To make up for the fact that I ruined it, I'm gonna unruin it. Check this out. How big was our diameter of the thingy? 25 or something, right? Yeah, 25. Yeah. You can extrude this by 1. Wow. Okay, now let's check the distance between this, and it's 9. You know what? No, we're just gonna have it be 10. 10 is a good number. Yeah. I think we just leave it at 10. Don't need a sketch. Here we go. Okay. Now we can finally add our chamfers. Yeah, that sounds good to me. Wait, I just realized something. The wires would go through where the linear rail is. Wait, hold on. Let's unisolate this thing. You know what? It's fine. You know, I can add a little cable channel. That's not too hard, so we're gonna just do it. Create a sketch on this face. Stop teleporting me to the origin, buddy. And then we just add a rectangle from there to there. Finish the sketch. Screwed this in like 5. And then I do the same here. Then it's easier to cable manage, and it's also like more chill like that, you know? I kid. Anyway, but now it's kind of cringe to print. So we're gonna fix the cringe to printness of this by creating yet another sketch, and we're gonna add a little triangle here. And this will help it be less cringe. I need to see that sketch again. Of the little triangles. There we go. And then I would like to have it start off of here. And then I would like it to... There we go. Look at that. Little triangles. Wow. Into that something. So now that's 3D printable very easily. And now we can add some chamfers to it. Good thing I caught myself. Okay, 2.5. What? Oh, it's distance and angle again. Wow, that is some wow and flutter in that music. Okay, let's see here. Where else do I need them? I should have one there. Have some there, probably. No, I shouldn't have any there. I'm gonna see what it looks like. Yeah, that's hideous. Do that. What happens if I put it here? No, we're not doing that. I can put it there, though. That's fine. But I don't think I want to, actually. Put it there. We can put it on here and here and here. We can also have it here and here. I don't think I actually want it there, though. No, we don't want it there either. You can put it here and here though. No, we can't. Unless, well, that is a cursed corner. No, no, and then yet another no. That's fine actually. We can have those be sharp. Sharp isn't necessarily bad. Put one on all of those corners, along with this one too. Just because it is more cool TM. What happens if I put it there? You know what? We will put it there. That's cool. What happens if I put it there too? Ew, what the heck happened there? Alright, we're not doing that one. Now I should put it here because it'll help the belt. That's why those ones are arguably the most important ones. The rest of them are just visual. Nope. Away, Jose. How about one here? Nope. Okay. That's fine. I think we're good. I think we are good. Don't really need that many of them. Boom. Hit OK. And now it is printable. Yay! We did it. We did it, everybody. We designed something that doesn't immediately suck. Good job. All right, let's send this to the printer. Now I need PTG. Let's see how long this will take. An hour. That's not that bad. That is not that bad. What if I printed in PLA? How long would that take? Nice. 40 minutes. That's pretty cool. How many grams of filament is it? 22. You know what? I've got purple PLA loaded up. Let's just print it in purple PLA. Color scheme? Who needs a color scheme when you got purple PLA in the printer right now? Right? Yeah, I've got purple. Okay, let's print. Wow. Now, the biggest problem with printing it in this orientation is that the angle in which it is being printed at means that this is where the layer lines are. And so if it has a place that it will want to break, it will be in the same vector that our force is applying in. So we're gonna see if that ends up being an issue or not. If it is an issue, we can print it instead on a different face, which would then make it like less printable, but it will break less easily, which is fine by me. I mean, I could print it this way, like having it, like printing it. Oh, I can't really flip upside down that easily. If I print it on this face, that would also change, but then the weakest link will be at this section. Now, of course, we've got a lot of space there, right? So it could end up just not being a problem, especially with like this entire layer being whatever. It's not going to be a big deal because most of the force is going to be applied through this into this side, which is compression, and that's not, compression is very strong, we're gonna say, but whatever the other one is, expansion, I don't know, the force of pulling it out is not great. Tension, the tensile strength of 3D prints where the layer lines are in this direction is not very strong, but it's okay because it's compressive force. So actually, I was just making stuff up for the fun of it. It's not actually going to be a big issue. Cool. So we'll see that in about 40 minutes or so. It's going to get loud, so let me close the printer door real quick. Wow. All right, next up, the grabber. You hear that, huh? It's like a hurricane just entered my apartment.
Actually, so my noise gate blocks it, but you can hear when I speak, that's for sure. Anyway, how about we do this now? So I need a spot for the badge holder. Now, there's a spot for the badge holder up top. Let me unisolate my Johnson. There's a spot that I can put it about here. In front of where the linear rail goes. Speaking of the linear rail, looks like I need to tighten it because it's wobbly left and right. So you know what? I'm gonna do that right now. In real time. Oops, I just knocked something over. Anyway, that's fine. That's not a big deal. What is a big deal is if I accidentally, like, it can just slide off of a linear rail and then it becomes an annoying issue to solve. So I need to be careful with my actions and my intentions while I do this. So chat, let's do that. So basically the issue with the way I designed it is that I have to undo like everything to get to something. And so it's actually pretty poorly designed, which is kind of my intention. I didn't want it to be, I mean, being good would have been good, obviously, but like, that was not like my goal. The goal was not for it to be good. My goal was for it to be easy and fast. It was very easy and it was very fast. So, you know, good job on that for me. But it does also mean that there are things that I might have to deal with, and one of them is this being cringe or whatever. So we will this. So I think I need washers where this is mounted so that it stops like breaking or indenting on the print. Actually, it's squishing the print basically, and squishing is not good, especially when something needs to be rigid. Yeah, it's very obvious, but that's okay. Also, I'm gonna need to put something on top of this to mount the belt holder anyway, or the badge holder, so it's okay if it's like a little bit cringe. Yeah, that's fine. It's not that big of a deal. All right, one more. Problem about having a magnetic screwdriver is that it sticks to my ruler, so that's very nice. So, get to see the inside of the, now you don't get to see, I guess. It's not that interesting, I promise. Well, I guess I can do this. There, you can see that now. Wow, ain't that crazy. Anyway, where was I? Tightening some screws. You can't actually see anything because I didn't turn on the light. Let me go get that real quick. The web UI can't turn on the light for some reason, so I have to do it manually. It's a little bit annoying, but whatever. You go off, Elegoo. You go off. Alright, there we go. That's better now. Tightened. I've got a heck of a lot of grease on this linear rail because my previous linear rail rusted. And so since I got a replacement that's longer, I don't want this one to rust. So I just slapped a buttload of like grease onto it. So hopefully it doesn't rust. If it does, well, I guess welcome to Taiwan. Alright, let's get some washers onto this, John, so it stops ruining everything. We've got some here. Now I think that might be for M5. I'm not sure. There's one. No, I've got a few. Okay. 3. And here is number 4. Nope, that's big. I have 2 sizes of washers. One small, one big. And I need the small one. Wow, it fits. That's crazy. Almost like it's designed to do that. This was set to auto bed level. It didn't actually need to do that, but whatever. You do you, printer. You do. The wrong size. This. Let's get the right one there. Boom. Okay. Oh shoot. Oh, it landed on my pants. Very good job, me. Let's get this thing put back together. And then once it's back together, we just wait for this thing. Well, we need to work on the grabber. The grabber is important, so we need to finish that. Yeah, I think I gotta restart my printer, or at the very least check for software update. Okay, there we go. The thingy has been put back together. I think it might actually be a PETG issue, where it's not like cooperating, well, where it's compressing actually. That might be a PETG thing. There we go, that's better. And so I might need to find a better filament than PETG for this. That might be the issue, but we'll see. Because I might need to start using ABS or an engineering filament. That'll cost money. Or maybe I just need to design things so that I don't need buttloads of force to hold them together. I don't know, we'll figure it out. Let me go turn the light on for you guys so you can watch it. There we go. Lights on. Lights, camera, action. Cool. Grabber 2 version 1. Let's get this version 1 version 2'd. So, let's measure how far off of the back of the linear rail are we allowed to use. We can do it from up to 1 to maybe 1.5. So let's see here. I don't want to turn on caps lock, bud. Let's get ourselves a distance check. How far is that from to that? That's 11. Great. So if I wanted to have the badge holder in here, okay, I don't know how to use software anymore. Then I could just like wrap it around where this screw goes. And that would be both, you know, pretty strong, and it would be, no, good TM. So let's just do that, I think. Or I can have it off to the side. Off to the side might be a better choice, but then it would make it less printable, so that would be cringe. So you know what? Let's just do it. You know what? No, we can have it be off to the side, but in a way that you do not expect. Actually, how easy is that? Okay, the real thing that I need to design around here for the badge holder is actually like the badge clip. The clip is big and bulky, and it also like gets in the way of things. And so I need to design the thingy such that that is not in the way of things. So let's see how long is this side actually. That doesn't even go that far. All right, how far is this line to this line? 50 millimeters. That is about the length of the badge clip. So if I put it there, it will technically be fine. Cool, that's good. So you know what? That's what we'll do. We simply just need to make a little bitty channel for this badge holder to attach to. And then it should just stay there. Can you hear the 3D printer? it's going. It's in the same room as me, so it can get loud. I like how you can see the motion blur, but not really the motion. That's pretty funny. I mean, it's not exactly designed for this, obviously. This is not really the use case for that 3D printer's like live camera streaming. It's more so you can check it as it goes, but we don't do things the correct way here. We do things the easy way. As easy is good. Okay, let's do this thing now. So what we need to do... wow, I already had it done. Good job, me. Actually, that's a little bit... yeah, that's a little bit too close. So can I have it cut on this plane? Yeah. Okay, it didn't work. Why? Section 1. You know what? We are just not going to deal with you. Inspect a section. No, not minimum radius. No, I want to see this thing cut in half. There we go. Yeah. We'll just do that. Okay, why did it make hole? I don't want to make hole. I would like to get a sketch on this face. Wow, okay, I can't touch it. That's great. Alright, how about we do that, but it's offset by 1. That'll fix it. There we go. Cool. So it should be really simple. We really just need basically a I'm gonna go with 15 because that seems like a good number. That's not 15. That's 15. And then we just need a really small channel for the belt holder to go through, and then just a way for it to not fall out. That's all. It should be pretty simple. So here's what we do. Yeah, we finish the sketch there. Then we click M to move the sketch object, this one, inside. Oh, what? Huh? No. Let us do that again. Move. Sketch objects. Translate this entire thing. Why is it rotating? I would like to move a sketch object. Translate this and this. 5. Did it do anything? No. Great. Alright, I don't know what I'm doing right now. What I'm trying to do... I'm trying to use pipe on this, but it's being lay cringe. Wait, what if I didn't need to do anything? Like, what if I just did that? Yeah. I mean, that would technically work. Alright, what's this do? What's this do? No. They're doxing me because they're lay cringe. Okay, let's get back to deleting this sketch. We don't need it anymore because it's annoying. Let's... okay. No, you're playing Terraria, that's fine. I don't really mind. What we actually want to do is a sweep. And then... yeah, we need a sweep. So... and then I need to make a path. Alright, here's what we're gonna do. We are gonna create a sketch here. Then, we're gonna take a circle. We're gonna put the circle... here. We're gonna make the circle 2 millimeters. And then... we're gonna create a rectangle. Center rectangle. About here. It will be 1 millimeter thick. That's thick enough to put a string through. Maybe. Okay. And then we finish that sketch. Then we take this dot, and then we create an offset plane there, extend to object, and then we pick this dot. Yes. And then we click that, we create ourselves a sketch, create a circle, we create the circle on this point, and we take it to this point, we click finish sketch, then we go over here, and then we click sweep, and then we choose this, and this, and then we choose this for our path, and wow, look at that, guys, I did it. Hello everybody, how's it going? Today we're learning how to use Fusion 360. First time I've ever done that. So that's where our badge holder goes. Now let's take the distance from here to here. That's 40. Now is that long enough for this badge holder though? We want it to be 45. Oops. Okay. Go back to the sketch. And then we can actually just grab everything here. No, grab everything here and move it up 5 millimeters. Click OK. Click finish sketch. And wow, look, it fixed itself. That's so cool. I love it when software works. So, from here to here is a distance of about 40 something. 45 about, roughly. And I think 45 is a good number. Yeah, 45 will do. 45 will do. Next up, for the saga of this thingamabobber, we need a place for our limit switch. Yay. I'm gonna put it around here somewhere. It will click on this thing. And then we also need a spot for our rubber band spring mechanism. And then we also need to expand this upwards a little bit. And then, yeah, that's it. So, it might be easier to actually do a version 3 of Grabber. You know what I need? I need a glass of water. I didn't get myself any water. Getting a bit parched, we'll say. Wait, let me see if my friend is outside and downstairs. Are you nearby? I'll give you $5 billion if you get me water. Or maybe not. Okay, message sent on Discord. Oh, my stream broke. My stream broke. There it is. It's back. We figured it out, guys. Wow, look at that. It's purple. It's purple because purple's the color that was in there already, and it is not. I have about 100 grams of filament left on that thing, and that was like 25. So we're just gonna use it up, because you know. Hopefully it's not cringe or whatever. Anyway, I need to figure out to what extent is. You know what? Let's measure the distance from this face. No. Measure the distance from this face to this face. 30 millimeters. Now let me grab my real life object. The distance is 30 millimeters from the bottom of the thing. So this is actually fine. We don't need to adjust this to make it any taller. It actually is perfect the way it is right now, which is wonderful. Isn't that so wholesome and nice that it's perfect the way it is?
Anyway, there's also a secret feature that I need to add. So, let me explain this secret feature. You know what? Here, I've got a great idea. I'm gonna do something real quick. I'm gonna go to the Family Mart, no, not Family Mart, the High Life that's downstairs from my apartment, and I'm going to go and get myself a drink. In the meantime, I'm going to keep what I need to do a secret so that you have to wait and watch and see what the change will be. So, enjoy your cliffhanger. I've got something really cool. Check this out. Check this out. Let me go into studio mode. Can you hear me? Okay, yeah, this is my my start screen. But let me just add my Firefox to this so that you can watch it. There. Yeah, I'll be back very, very soon. Wait, let me add paint as well so that I can just write I'll be back very, very soon. Let me figure out where paint is. There we go. Alright, where was I? OBS. Okay, I'll be right back in a little bit. Let me get Firefox on top so you can see it again.
All right, we are returned. I'm back. Yeah, that's me. Yeah. So my apartment is on the 5th floor. Which, you know, and there's no elevator. So I get to run up 4 flights of stairs every single time I go downstairs. Yippee! Yummy drinking ASMR, yay! Alright, you wanna know what I got? I got Oi Ocha, sugar-free green tea. Yeah. That's what it's about. You're having dinner at 2 p.m. Okay. I'll be around. So later in the stream, we might have a cameo from a friend. He's coming over to pick up the bad 3D printer. I don't know if I've told you about this, but before I got my good 3D printer, the one that's being used right now, I had a bad 3D printer. And this bad 3D printer is that dab? This bad 3D printer is actually from a friend, and so I have no use for it anymore, and so you need to give it back to this friend. However, this friend is off in Australia. Now, you might be thinking, why do you have a friend in Australia? I have 2 friends in Australia. Well, one of them has a 3D printer, and the other one does not have a 3D printer, so there's actually 2 friends in Australia. Anyway, I need to give this 3D printer back to them. So that'll happen eventually, but for right now, I have another friend who will come by, pick up the 3D printer, and take it to someone else's place. Now that someone else isn't actually at their apartment either, they're somewhere else. I don't actually remember. Thailand? I don't know. But they're somewhere else too. So, in short, a friend of mine is coming to my apartment later today to pick up a 3D printer for a friend. Well, not for, but to pick up a 3D printer to take it back to a friend. But that friend's not here, so he's taking it back to a different friend's apartment who's also not here. And then taking the and then eventually when they get back, it's not a big deal. We're not gonna worry about it. What is important to worry about is we need to do grabber. Grabber is important. Grabber is like the #1 most important part of this entire project, I think. So we need to get grabber. We need to do grabber. So let's do grabber. How's that sound, everybody? Let's do grabber. Okay, grabber. Let's grab some cards. So what do we need to do for grabber? We need to grab the cards. I think that's pretty obvious. Mmm. Yummy. Okay. So, let's see. I need to think real quick. Like, what if this entire grabber idea is fundamentally flawed? It's like, what if the bin, because how big is this? This is like 1 millimeter or something? Yeah, that's not a lot. It is fundamentally flawed. That's cool. But is it that fundamentally flawed, or is it only a little bit fundamentally flawed is the real issue? I think it is a combination of both. Well, we can print it out, see if it works. If it doesn't work, we get back to the lab. It's not that big of a deal. Besides, fail fast, right? That's what Mark Zuckerberg says, and he seems to have been somewhat successful in life. So, we shall take his advice. But real talk, how long or how far apart are these? 67. That's the exact same card dimension, right? No, that's not. That's a little bit bigger than a card. A card is roughly 63. So 67 is a good bit bigger than a card. Maybe what we do instead is we take these. These are 90 apart. If we made that the exact dimensions of a Pokemon card, right? Instead of having a 2 millimeter gap, you can either take that down to a 1 millimeter gap or even a 0 millimeter gap. Because then we have more space for like the side thingies, but then it also becomes a bit of a pain to like take the cards out of the bins. So you know what? We'll just. So how big is this? That is 20 millimeters. Wait, you know what? I just realized something for the bins. We don't actually need them to like have sides. We just need to have them like be like this vertical section. So that's actually okay. So I don't know. We can test it out with this design for the grabber, and then once we realize that it is fundamentally flawed, we can do a new design. That's okay. That's the entire point of iterative design, is that you test something, it doesn't work, try it again. Now, we get to make a decision for this part that goes up. You know what? Actually, it's not that difficult of a decision. We do it the correct way instead of doing it the idiot way. So we're gonna do it the right way. So this is 13 millimeters, meaning that, wait, that's 15 millimeters. So that means that off of this, you need to go up 15 millimeters. And then, so we'll create a sketch on this face. Choose this point, and then we'll go up 15 millimeters. And now that we're up 15 millimeters, this is where we're going to have the clicker. Not clicker, you know what I mean. The end stop is the word I am looking for. The end stop. So this is where the end stop will be. Actually, you know what? I had a better idea. We can have an adjustable end stop. So what that means, we're not going to do this. We're not going to do that. We're not going to do that. What we are going to do instead, we are going to have holes in this face. And we will simply put screws into those holes, and then we can design something that goes on top that has slots, and then I don't need to be accurate. It's faster, and it's also adjustable, because what if it needs to be lower? What if it needs to be higher, right? So I will actually do it that way instead. So where do we put these screws? We're gonna put them here because I can. 3. Do I want 3 or do I want more 3 or do I want less than 3 or what? You know what? We'll say 3. Yeah, that's it. I'm pretty sure that's all I need. I just do that and then I go in like, let's go 20 just for good measure. Yeah, that's fine. Doesn't really matter that much. Anyway, there we go. Problem solved. Woo! We did it, guys. We designed the end stop. But anyway, now I can print these parts. Well, no, I can't because I need the secret. Oh, right! I had you guys cliffhanged. I'm such a bad streamer. So, the cliffhanger. What is a cliffhanger? The cliffhanger is that we need to take pictures of cards, right? And I might have already said this. Yeah, let me figure out where my Microsoft Paint is. Here it is. I might have already said this, but the way we are doing the pictures is we are taking pictures from the bottom. So this is the bin, right? This is where our camera will be. So it'll be facing up like this. And so our grabber, what it does right now, this is a stack of cards, by the way. No, that's a horrible stack of cards. This is a stack of cards, by the way. It's still a horrible stack of cards. Okay, this is our stack of cards. What it does right now, it goes down, squishes it, grabs one card, and then it lifts up that card. What the heck? And bends it. Right? Actually, it's not gonna be like that. It'll be more like this. Right? That's what it does. But that's problematic because what we're doing, this is our bin, right? There's our camera. And then this is the card. It's gonna be bent when we take the picture. Exaggerated for artistic effect, but you get the idea. Right? It's gonna be bent. Right? And so when we take the picture, it might look like it'll be fine, but the lens is designed such that that will actually be warped. So the card, when we take the picture of it, will look like this. Right? And that's suboptimal for image recognition, we'll say. So what we need to do is we need to somehow design a way such that here's the frame of the robot. Right? Such that when our grabber, this is the grabber, we need a way to hook it onto a section of frame at the top so that if we lift it up past a certain point, so like when we're doing the part that we're not taking pictures of, we can keep it underneath this point. But when we're taking the pictures, we can have it above so that it grabs onto the circle, and then it can lift up this section, because remember, the suction cup is on its own floating mechanism. That's the suction cup mechanism. And then this is the grabber. And so what we need to do, we need to get the grabber part to go up, and this part needs to go down. So that then the card will basically be flat. That's the card, and then this is the bender part. Basically, that's what we need to do. It's this. See this? That's what we need to do. So how do we do that? That's a mighty fine question. And I haven't exactly figured it out yet. But I have a couple of ideas. What we can do is at the top, we can have it such that there's a hook on the grabber, right? But the hook doesn't actually have to be that long. Like this can be our grabber, for example. And then this can be the hook, right? Now, it might not go all the way, but at the top, what we can do, we can have what is essentially a bolt in a like channel, and this can be spring loaded. Like we can have a rubber band, for example, and the rubber band can hold it up, right? Like that's a rubber band. Horrible drawing. Or like we can have a spring. And so it'll go up, pull it down, and then this will go all the way until the point where we need, because remember, we're not taking the picture at the very top. We're gonna take it in the middle somewhere. Now, I don't know where that middle is, because I haven't built the thing yet, so I haven't taken any pictures yet with the camera, so I don't know where its focal point is. I don't know where the best, like, lighting is and whatever. So this needs to be adjustable. This needs to be adjustable. And so, like, it's easier if I adjust it here instead of here, right? So, what do we do? I don't know. So, like, this is fairly simple, but it's also a bit silly, don't you think? Because then it will need to go onto the frame, and it will be in front, and it will be like that, and it will be really ugly. So what else is there? There's, I don't know. I simply don't know. But like the idea is that because our end stop is connected to this, by the time it gets to where it needs to be, it will click the end stop, and so we'll know where we're gonna abuse the probe G code thingy. We're gonna abuse the probe G code command. Oh, my Firefox froze. Here, let's Google that. So let me show you the software that we're gonna be using. I don't need to have this showing anymore. This is the software we're going to be using on our Arduino to control the entire thing. We're going to be using Gerbil. Notice that it was last updated in 2019, but that's because they pretty much just like got the very like they like squeezed all of the juice out of a single Arduino Uno. But basically, you look here. I don't know, where is it? GRBL probe. You know what? Here. We can read the instructables. That's good. Yeah. I mean, this is what we're going to be doing, right? We've got an Arduino CNC shield. Because we need to remember, a card splitting robot is just a CNC machine. So it's actually very simple. Here, let me check this out. Actually, I've got my Arduino somewhere around here. Oh, there it is. Found it. It's actually an Elegoo Arduino, which is really funny because my 3D printer is an Elegoo printer. This Arduino, well, Elegoo Arduino, I guess, came from my high school, and we had a class. It was like it was like something about electronics and design or whatever. It wasn't like very well run, but at the end we like built a thingy, and in it was an Arduino. And so last winter I disassembled it, harvested the Arduino to use for this project. So thank you, high school. Anyway, yeah, okay, so there's SCL and ground pins on the CNC shield. That is true. so I should probably figure out exactly how this works. Now I am hoping that I can possibly disable the retract, because we don't need to retract. Basically, we just need to know where it is the first time, and that'll be good enough. Because we're not doing precise milling, we're simply putting cards around. And so if it's there, it's there. We don't need, it's not that complicated. We're really just using it as a way where we don't need to remember exactly where everything is. That's all it is. I mean, we can take the probe measurement and use it, yes. But, we really kind of don't need to. So, yeah. This is something we're gonna have to figure out via experiment and not just exactly by reading. Oh, look, our print's done. Okay, let's go grab it. Let's go grab it, guys. Look, it's there. Right, I'll be back. Wow, chat, hand reveal. Okay, it looks fine. It's just a PLA part, I guess. I don't know. All right, let's see how well it works, I guess. All right, let's grab our end stop. Can confirm it fits pretty well. Yeah, it does fit very well. Oh, that's perfect. Great. And then the wiring channel is the wiring channel. It's not that complicated. Now let's see about the M5 part of it. Let's see, what sizes of M5 screws do I have? M5 by 10, we'll use that. Ooh, wait, this one's better, I think. Yeah, no, this one's way better. Okay. Let's, should I set up the camera? I guess I could set up the camera. Well, it's already in, so it doesn't matter anymore. Haha, like that. Oh wow, there you go. Cool. You know what? Let's finish putting this together. All right, let me show you guys actually. Let me figure out how I can. I don't really have a good like camera mount setup though is the issue, and also my microphone is facing a completely different direction. Maybe I should pay for Droid Cam Pro. I think it's probably time. Does this work? It did not work. Oop, chat, I broke it. Uh-oh. Uh-oh, chat. Oh wait, no, I didn't break it. Okay, what is this number? Oh, I'm just not connected to Wi-Fi. That's all it is. I am very intelligent. Yeah, I know. All right, it should work now. Yay! We did it. Okay. So, how do I do this? Grab this, I guess. Oh, shoot, I just dropped my head. You know, maybe we don't film this part. You know what? Here, we can go back to Fusion. We can go back to here while I put it on, and then I can show you after we do that. How's that sound? Please by some numbers. Okay, let's see here. Here's a screw. We just need this to go through. Okay, there we go. Yeah, okay, so M3 by 16 is a fit for that. So we will use 2 of them there. Uh-huh. I feel like I didn't make it loose enough, but that's okay. Screwdriver ASMR. Everyone's favorite. Everyone on this channel loves screwdriver ASMR. I know. It's just everyone's favorite. Alright, let's get that screwed in there. Okay, boom, pop. Okay, great. Now, I will deal with the end stop later. I just need 2 T-nuts so I can attach this to the thingy. Oh, you know what? I need to remove the thingy. Oh, I can do that by hand, actually. That's not good. Oops, uh-oh. Okay, let's get this out of here. I can put this belt through and then put it back. Alright. Yeah, I shouldn't make this hand tightenable, but oh well, it's too late. It's already been made. Anyway, that's cool, I guess. Alright, the nuts are flipping. Alright, T-nuts are on. Let's mount this, John. Haha. Grinding. Basically a poet. Get these. Made the whole. No, actually. Oh, I just got my hand super duper. Good job, me. Good job. A+. Oh wait, I'm also putting it far too low. I need to check my model so I know where to mount it. Did I add any like good markers? Okay, so that needs to be 5mm. Good thing I did that. Tighten these. Tightened. Good. Alright, let's get the other one tightened in. Alright, there we go. Ow. Is attached. Good. Once again, it's in compression, so it's probably fine. Alright, now we can mount the other side. And then I just need to shorten the belt, really. Oh, shoot. Oops. Uh-oh. I put the belt in upside down. Luckily, I can unscrew this with my hands. Oops. Uh-oh. I mean, it should not be able to be undone with just my hand. But once again, this is the first easy one, so it doesn't have to. That is what is important, is that it is easy, not necessarily good. Oh. That's in. This is in this side. Go. Wow, look at that. Wait, that's great. Alright, I will tighten these belts and I'll show you what happened after the fact. Give me one more. I just need to I need M2.5 2.5 mil. Hold. What? I have Allen keys. I can use those instead. No, Allen keys are. You know what? Maybe we do use Allen keys. Yeah, we are going to use Allen keys. Let me go find those. I have them in the apartment somewhere. TM. Good luck me, good luck. Alright, maybe it's somewhere else. Alright, I found them. They were in the drawer where they're supposed to be. Wow, I put something away. I'm so good. I'm so awesome and reliable at putting stuff away. You know, this seems really boring. What should I put on the screen? What should I put on my screen? This is really boring. Oh, I got it. I got it. Hold on. Whatchamacallit? No, hold on, let me remember. Let me use my brain for a second. Subway Surfers. Videos. There we go. Yeah, this will do. Yeah, I don't care. Okay, there we go. Alright, now I can yap. While, you guys don't get bored. All right, let's get our 2.5 or wait, is it? Oh, it is a 2mm Allen key. So let's get that so that I can loosen this thing. Lefty loosey, righty tighty, right? Right, let's do that. So that I can then tighten my belt. So cool. Alright, it would make it easier if the belt would stop like everywhere. So get that tight. And then tighten via righty. Okay. The screw is being tightened real quick. Then I can show you what I just did. I finished the visual screw. Oh yeah, and then I can also add the belt. Good, it makes a really weird rattly noise. Alright, I think I know where that is. So on the right, it's fine. Rattly noises on the left. That means that our stepper motor mount is a little bit too low, but I can fix that very, very quickly. Actually, it's gonna be a bit longer than very, very quickly because I have to completely undo the entire stepper motor, like attachment and stuff to adjust it, which is really, really annoying. But I can just do that real fast. So let's get this thing removed. Bunk, yep, that's a good sound. Okay. Alright. Thingy is out. Let's move this slightly up. Okay, not that. Do not have the original. What? We can put stepper motor back. Yeah. Pull it around, out the stepper motor. This back. Okay, there we go. A little bit more. Okay, Now it's not making any weird. There we go. Great, we did it. All right, so basically now I know that it needs to be a little bit up. Okay, got it. Okay, so basically it needs to be in line with the aluminum extrusion. So that's easy enough to, because it's measured for me. There. On the bottom too. Cool. There we go. All right, next up, we need to put the stepper motor back in. Okay, that's very easy. I just put it in. It a little bit, and then there we go. Good. Oh, clunk. Clunk is okay, guys. Clunk is okay. All right, and let's screw the stepper motor in. If there's one. Now it's stable at the very least. Condition stable. The patient's condition is stable. So that's great. Is my aircon running? It is running. Oh, very. Okay, now I just need to tighten this a whole bunch. Yeah, we might be getting a cameo soon of one of my friends. We'll see. That belt should be like that. Okay, great. So if it goes all the way there, it goes click. Okay, great. Wow. Wait, this is awesome. Wait, it's actually like coming together, which is cool. Okay. Okay. Let's see here. Let's get the belts, because the belt is in the way of a lot of stuff, so we need to cut the belt, and then we need to add the little tensioner doohickey, and then it will be fine and dandy. So let's adjust this belt real quick. Oh wait, that's righty-tighty. Tightening it. Upsy daisies. I didn't break everything. This belt helps a little bit. Right. Now, yeah, okay, that's very strong. And now we just need to do the same on the other side. And then I show you guys what goes. Oh. Incredible, guys, incredible. Okay. So, now I can apply one of these belt tensioners. Yeah. You get to see the glory of, belt. Yeah, you get to see belt. Wow. Aren't you excited to see belt? Belt. Okay, how far forward is that? And this will always. Okay, we're gonna put the belt on the stepper motor side because it makes. knew that a belt tensioner. Ow. Tough. Oh. I wish I had a camera mount so I could show you guys what I'm doing. Oh, maybe I should 3D design and model one of those. Ow. Okay, how are you supposed to do this? Let me get some pliers, I'm going to do it. I only have one. Okay. It's just a spring, really. Okay, there we go, I got it. Yay! Yay, belt tensioner is in. Ow, I just got grease all over my finger. Good job. What's going on? I am doing something very cool. Alright, I can show you how much. I can show you what got done though. I can't really show it on stream because it's like in real life. Okay, anyway, let me get my camera out. Oh, that's not camera. Get the camera. An app. Okay. Let me click the button. Boom. Wow. Okay. Here's what we did. So this is the gantry that we were doing before. This is the part we designed today. Now the limit switch goes right here. It's just not installed because I don't have the right size screws. I can do that eventually. And then that's the stepper motor. And so now basically if I spin the stepper motor, it moves. Wow, look at that. Woo! Yay! That's an epic victory royale. That's the belt tensioner. You see that spring that's not focusing on? Fringe or whatever. Can you focus on this? Yeah, see that? There it is. That spring, that's the belt tensioner. But basically, you can go left and right now. Boy. Now, all we need to do is make it go up and down. So the grabber is one of the parts, and then I need another part to get attached to here. Top, and then we can have it go up and down as well as left and right. And then we're basically done with the the motion system. And then after we're done, since we're done with that, then we can get into the electronics. We've got our Arduino right here. Basically, we got our Arduino. And then these slots are where the stepper motor drivers go. So let me go grab one of those. So basically, you take your Arduino, right? Now I don't remember exactly which direction it goes in, but basically, this is a stepper motor driver. So this thing basically controls the stepper motor. And well, it basically takes your normal like power and makes it into a power that the stepper motor can actually like accept. But anyway, it goes in. That's probably upside down. Here, let's figure it out together. Well, I need to actually read. That one says EN. That one says C1. That's not very helpful. That one says C2. And that one says EN. Alright, which one of these says EN? Oh, okay, it goes like this. So yeah, it goes in like that. And then we take the power from our stepper motor through, I have the wire somewhere. Here. Through this wire. This gets plugged in somewhere around here. I'd imagine it's these. And then this gets plugged into the stepper motor. And then we, then yeah, we're good. We also need to attach our end stops to here, which is where the end stops live. So yeah. Now so the the software that we're using, Gerbil, the controller, we have solenoids that we need to control, but we can control the solenoid using, basically, we can pretend that the solenoid is a fan. So when we need to open the suction cup, we just turn on the fan, and when we need to close the suction cup, we can turn off the fan. And basically that's how we will do it. Yeah. So yeah, there we go. Isn't that cool? All right, we can go back to looking at Subway Surfers. And let's see, what was left to do? Well, let's see. I don't actually need this. All right. I do need to be able to read chat though. That's important. Okay, there we go. Okay, great. We can get rid of this now. We don't need Subway Surfers. Wow, it feels good. Feels good to finally have part of the project done. This is like the hard part, basically, is making sure that this entire, well, actually it's easy and hard at the same time. Is it easy? It's easy in theory. It's theoretically very easy to do this, but then like to actually get it done, like it feels good. You know what I'm saying? But anyway, yeah, so this, now we got left and right. We have left and right. Just two more. Well, one more. One more dimension is what we need, and then we just need to print the bins, and then I'm gonna have the bins. They're just gonna be 4 sticks, I believe. I think the 4 sticks, or is, well, one, it's more efficient, like material wise, and 2, it's just like here. So we need to figure out how are we going to do the grabber, because we need, remember, we need the grabber to only go a distance. I have it in Microsoft Paint. Right, so we need to have the grabber part go up somehow, but like not that far up. I don't know how we're gonna do that. A sip of tea. Yummy. Okay, well, I can save this. Wow. Okay. So I also need to figure out how to do it while also dodging this thing I made. It shouldn't be that difficult because I can use this like section, but still. I also need to be able to dodge this assembly that's up at the top. But that's what, I mean, I have this space over here. I also have this space over here. So I can use like this corner, for example, up and grab it. The problem about using that corner is that it interrupts this, so maybe we have to use, or well, let's see. Oh yeah, we can't, because that's where the belt goes. The belt goes on the inside corner. Actually, we have to have it on the outside. Wait, let's see. Is there a way I can have the thingy be attached to the camera mount, the camera bin, which then might make it easier or more difficult, I can't tell.
Could be easy. Huh. Curious. Because, like, the thing is that I need to be able to do it based on how the z-axis. Well, the x or the z-axis, yes. Because here's what I'm thinking. Figure out where it is. Okay. No. Here's what I'm thinking. Right. We have our bin. And so, like, that's a horrible bin. So, we have our bin, right? So what if we just attached it to the outside of the bin, right? Like, what if we just did that? Like that. And then this is where our thingy is. Right? I could just do that. So that's an option. But then it brings upon the issue of how do I control whether it's grabbed or not, right? Because I need to be able to control whether it's grabbed somehow by only going up or down or left or right. Right. Now I already dismissed left and right because remember, we don't have that much space in between this. So left and right is not really an option. So the only thing I could think of was up and down. But like, what if we had a way to do it left or right, right? Now, I'm not sure how I would do that. So that's the issue here. How the heck do I make it go left and right? Or up or down. Sorry, I just need to think. What a curious issue, huh? Why is there a dot down there? I like how when I scroll, the dot disappears. It's really funny. See? That's really interesting. Okay. Here's what we can do. At the very top of the bin, I don't know. Very top of the bin, what? I don't think it's possible. We do need to just have it be long, I think. I think having it be long is okay. It's just slightly undesirable. But either way, we're gonna have something be long, so it's okay, I think. The answer. So I think we can just have something be long. Wait. I just realized something. No, it's not something serious. I had another idea where you use basically like the clicky pen mechanism, you know, where it's like you have a channel goes like this, and then it's like this. The clicky pen mechanism. No, that's not how the clicky pen mechanism works. The clicky pen mechanism works like this. Nope. No. No. Okay. Clicky pen mechanism works something like this. Yeah, like that. So like, I could do the clicky pen mechanism. where it goes up and then it goes like that, and then it goes up and then it goes like that. And that could also solve the problem. But how do I trigger the clicky pen mechanism, right? I mean, I could do clicky pen mechanism based on whether it reaches the top or not. Then it would click. I mean, that's always something I could do. So, because there's another way to do the clicky pen mechanism where it's not ugly like that, but it's based on like a line. So I could always... Because I don't need to have it retract at the very bottom. It can retract anywhere. It just needs to retract in the first place. So at the top, I could add the clicky pen mechanism such that it's really simple, where it looks something like this. So it will be from the side, and then this will be like in it, right? We'll have a circle like that. Then I believe if I make the profile look like this from the side, or it's like that, and then there's a lower section here. It's not that complicated. It's not that complicated in theory, but it's like really hard to explain. I don't know how, I don't know why. But basically you just have this, and it is always pushing in like this, right? And then on this you have a channel, and it basically looks something like this, right? That's really horrible. Wait, hold on. I just realized something. Because I just need to be able to control whether it gets locked in the thingy based on how high up it goes. I don't need to be very precise with like everything else, meaning that I can theoretically do what I was just describing, but easier. So if I have a profile that looked somewhat like this, like that from the side, and then from the front it would look like this. This is the channel, and this section is this, right? And then from there it would just need to look like this, basically. No, it would just need to do this, and then here is where that ramp is, right? And then I need a little bit of a little channel here. Basically, I just need it to not fall back into that hole. Now, it's easier actually so we have our profile, right? It looks like this, just for demonstration purposes, right? Now, no, horrible, like that, right? And then for the other side, I just have, so we have the thingy. This is the pin that tracks, right? Now if I just have the pin always be pushing that way, it makes it even easier, because I can simply just have this hole, right? This is that hole, this is this hole. And then here we have a channel, and then we just do this, and at this channel, this basically needs to go, here, how about we just go to Firefox and type in clicky pen mechanism. Like, it's not that complicated, but it's also complicated at the same time. So it's like, it's really hard to explain if you ask me. Types. That's not helpful. Here. Nope, that's just the normal clicky pen. We don't need the spinning kind. The spinning kind is too complicated. Because there's a straight line kind. And we need the straight line kind. Flat retractable pen mechanism. No, that's not helpful. Like it's really hard to like describe it, but I know how it works. It's just I'm having issues articulating the manner in which it works. Bistable, like that. No. Here. No. Good grief. Alright, we're gonna go back to drawing it. But basically, here's what we can do. Hold on, do I have a pen right here that... No. Good. Very good job. Very good job. Excellent work. Alright, let me think this out. So I can draw it and articulate my sentences correctly. So at the top of our bar, we'll have a hammer. And then we will have our locking mechanism for the slider. It's at the top of the bar. Wait. Hold on, how does this work though? At the top of the bar... No. Okay, here, let's draw it out. We have our bin, right? No, this is gonna be what we call the grabber. The slider. It looks something like this. Okay. And we need a way such that at the top it can either lock in the upwards position or remain flexible. Which means that at the top, somehow, we need to retract it. I don't know how we do that. Or at the top we have... Here. Maybe we don't retract it at the top. I've got the old one here. Let me play with it a little bit to see if I can think of something. So that's how it is, right? Yeah. It goes up and down. I need a way to keep it up. but I'm never ever like attached to it. It's always floating. It's always a floating part separate from everything else. So how do I control it? I have to have a second separate part that like locks it. So how do I lock it based on height and distance? Okay, I think I have it. So, you know how we have the bin? Right, this is the bin for the cards. Now you'll notice that right now it's inside the bin. But what if we made it such that at the top, what it does, it triggers a mechanism that somehow gives it these little wings. Right? Then next time when it goes into the bin, it gets caught at the top and it doesn't go all the way through. Right. Then we can decide whether how high up it goes by changing the dimensions of these wings or the size of the sides on this, or by the bin height itself and the camera height. So we have a lot of flexibility basically in that. So how are we going to have these wings pop out? That's something I need to figure out. How are we going to pop out? We can always at the top have the clicky pen mechanism again, but like this time, because what we can do, we can just have it rotate out. Like the wings normally could be like this, right? And then when we need them to pop out, they can just pop out and look like this. So how do we rotate it like that? Wait, I just thought of something. At the top, here's what we can do. We can have this be on a free rotating pivot basically, or maybe lightly frictioned or something. So basically, whenever you move this, it stays where it is. Then at the very top, what we can do, we can have a sort of mechanism where it looks like this. This is a part that's sticking out. And then below it, we have another thing that looks like this. Right, that they're at different layers. This bottom one, you look at it from the side. So from the side, basically, it might look like this. With this being this, right? So basically, if you move it to here, then the triangle will look like this. And then if you move it up a little bit further, then the triangle is able to slide out and it'll be like that. Alright, 1 second. We're getting the cameo.
Alright, we have a buddy coming upstairs. I think this solution is dumb and silly. It's not gonna work. So, here's what we're gonna do. Command Shift New. Okay. We need a way for there to be a tab, basically, a lock. So how do we do that? We'll do. How do we do that? Or maybe like a one-time like trigger, right? Like what if it like would go, what if it looked something like this? Where it would go in, right? Like if it rotated around this pivot, where it would go in and then on the way out, it would close. Or no, not like that, but like would look like this. So it would get caught on a trigger there, it would get caught there somewhere, and then on the way back out it would rotate it. You know what I mean, right? It's like basically when I like when it goes in, basically it will stop where it needs to stop, right? But then somehow, I don't know how, maybe on the bin you have like a pivoting like arm, and then it like has a spring in that way, and then it gets caught at the top of the thingy like that. Hold on, the door didn't work. Oops, I kicked a bag. Sounds like it. Okay, we're getting our very first cameo on the stream today. Wow. Isn't that crazy, everybody? I know I'm not very entertaining right now, but I'm a little bit occupied with having to figure out how the heck am I going to get this thing, this bin, like locked, you know? Because, okay, if it rotates around this pivot, and then we're gonna need to have a force that goes directly that way. If we have a force that goes like this, then it will just swing in. All right, check it out, guys. Cameo number 1. About to enter the door right now. And his name is John Cena. Hello. You want to say hi to chat? Chat. Help. Okay. Just put it on the couch next to the popcorn maker. Huh? Yeah. Look on. Cool.
Where's your stuff? Shit. Second part done.
I did 2 batches. So there you can have the pleasure of peeling off. I did the first batch of. I have the pleasure of doing these.
Good.
Oh, there you go.
Yeah. You gifted. That would do a face reveal.
No, I'm not gonna do a face reveal for 50 gifted. Besides, this is YouTube. There's no gifted subs. Wait, there are. No, I don't have membership set up, so you can't do any gifted. Womp womp, isn't it?
How much are we at on?
We're halfway. Well, a little bit under halfway done. That's 2 of the 5.
Wait, for one filament?
Yeah, I look at the roll. That's one.
What can you put?
Huh? I printed that part for. Oh yeah, speaking of the card printing robot, check this out. Ooh. Ow. Wow. Wow.
Wasn't it just unattached? Like,
Yeah. Yesterday. I did it right now on stream. You can the VOD.
wow.
Wow.
The like, patience.
Yeah, hit that subscribe. Make sure you smash the like button, ring that bell.
The sponsor.
Huh? This video is sponsored by me and myself.
Geeks.com.
Yeah, that's right. This video is sponsored by Skillshare.
It's not ours, is it?
No, that's Jack's, yeah. No, that's the other one. Not mine.
This?
Oh, that's, yeah, also his.
Actually, for the
No, it's... I just don't like color change. So it's like, if I steal it, then that was original. Now there's a light bar that also originally... Put the light bar off, because...
right?
Yeah. Alright, chat. I know I'm the best. That's recycling. Nice. Very good.
It was on the floor already.
Yeah, I know. Goodbye. See you later.
Very cool. Watch it.
Yeah, you can watch the VOD. Alright.
2 out of 5, right?
Huh?
2 out of 5.
What? Yeah. So bring me back the bag, though, because it's very useful. Or you can just have whatever. Eventually, I'll take the bag back, so then I can put the next batch in the bag. Okay, that sounds good. Then we can play some Mario Kart World. Okay, chat. Let's get back to work. Right. Bud is leaving. Bye. Okay. What do we need to do? We need to draw. We need to design our mechanism. Wait, I'm such an idiot, chat. It's so easy. Wait, no, it isn't. Wait, yeah, it is. Wait, no. Wait, yeah, it is. Wait, no. Wait, yeah, it is. Okay, it is easy. Okay. I was just doing it backwards. Here's what we actually need to do. It's really simple. This is it. That's all you need. Basically. Oh, and then the pivot is on this. Basically, it goes in, right? And then it just like hits the thingy. Then on the way back out, it gets caught by a little peg. Now this peg, maybe not a peg, a little rectangle. A little rectangle. Oh, okay, a little rectangle. And then it gets sucked up like that. Now, this rectangle from the other side looks, so this is our triangle that is moving. This rectangle looks like this. Right? And then it's like this, and then this is spring loaded. So like that, let's say. Therefore, when this goes in, it will move that out of the way and lock it in place, and then it can do its job. Then on the way back out, this can do its job and move this back up. Is that good? Is that good? No. Is it? It's also not easy. It's not fast either. Shoot. Maybe I'm doing this too complicated. Do any of you have ideas for how to solve this issue? 'Cause this ain't it, Chief. Well, there is the dumb solution. We can always do the dumb solution. Want to do the dumb solution? Like, what if we did do the clicky pen mechanism? What if we did the clicky? What happens then, right? Clicky pen mechanism good? Bad? Does it solve our problem? Pen mechanism? Bug. Yeah, that sounds about right. I don't know why my chat is so broken. I should probably fix it. Let's see. We need the thingy. To be up or down depending on a factor. Now, we don't know what this factor is. We don't know what we should use for the factor. All we know is that we need a factor of some sort. So, what is it? What do we do for it? What is that loud noise outside? Truck. Okay. So I had the idea earlier, right? With the hook. Go up and hook on a thingy. And then the thingy has a slider that lets you adjust exactly how far down you want it to be. And then it's like got a spring and it'll return, it'll go down to there and then it'll return. That means spring. Now this technically does work. This does do what we want it to do. But the issue is that it's really big. And I don't really have a good place to... I could mount it onto the camera bin, which is an option. Check out the grabber real quick. Because I could put it, the assembly here, and basically this part can go up and grab it. The real problem of that is that the grabber section has to be like at least, I don't know, 10 centimeters. Because that's the range of motion that we need to have up and down. What if we just tried it? If we just tried it and said, you know what? Yeah, what if we just did it? The real question then becomes, how far down do we need it to move? But I guess that is the part where we can make it be adjustable, so that, because we haven't done the camera. We don't know what the best distance for the camera is, lighting wise and whatnot. So we can always, like focal distance wise, well. So we can always figure that out via heaps of adjustment. I think what we do is we make it part of the bin, and then it can grab it, because it has to be at least up here. Otherwise, no, it has to be really high up. Otherwise, it's not, you know, far enough to clear it. Because remember, we have to get this entire assembly above the bin. Meaning that... Get my paint again. Meaning that our bin can be here too, right? And then we have to make our decision based on something all the way up here.
Or at the very least, something here. Right? That's the very least distance that we can have it be. So that's the bin plus this distance d. And then like plus or minus 10 or something. Plus like how do we do that? How do we do that, everybody? If I made it part of the bin, then the bin becomes taller. And then that's another issue. Because then the bin has to be designed to be taller, and then it has to be bigger. And it also can't be that big, because it has to, you know, it has a very limited, like, area of, like, existence that it can't exist. Another issue. I don't know, maybe you could slot into the bin and then it's not as big of a problem, but once again, I don't know. I don't have a good solution for that. Have I spent like the last 30 minutes with Microsoft Paint? Yeah, that's great. But like, we need to solve this problem. This is one of the big problems that I haven't like actually solved yet. The rest of it is very easy and has already been done. But this is something. What do we do? What do we do? I wasn't listening to music, I had my headphones off. Now I have my headphones back on so I can listen to the tunes I've got running. So we can have the clicker pen mechanism. What if we figure out a way to do the clicker? I feel like that would be optimal. Because then we can decide before we actually go into the bin, and then we won't have like a large like extrusion anywhere. Because the large extrusion is also the place where it's most likely to break. I'd really like a way where I'm not reliant on the really large extrusion, because another problem of the really large extrusion is that it might not work as well in 3D. We need to also remember that we're designing this robot not just for 2D but also for 3D in the future. So, you know, we need to be cognizant of that. Magnets. Is there any way where magnets could solve a problem? I have some there. Like, could they solve the problem in any way? I don't think so. Wait, I just thought of something. Clicker pen mechanism. But hold on. Like, what if... Hold on. Okay. So hear me out. What if we did it such that... New. Okay. Here, I've got a great idea. So, we're facing in this direction, right? This is the direction that our grabber will be facing. And then the suction cup is in here in the middle, right? But we can't actually get to the... So, that's actually completely irrelevant. But, we have a little bit of extra space to the right. Right? So, basically our bin can be like this. Right, so this can be our bin, that's our grabber. So, because of that, what if I did a clicky pen mechanism? Right. But hear me out. Clicked it on the bin. And then, to unclick it, you ever see those mechanisms where it's basically just this? So basically this is just the pen, and then you have a button here. Right? So like, what if it clicked down there, it took a picture of the card, gone up, unclicked it, and then put it where it needs to go? No, that's silly. Or maybe, here, let's see. Because we need a way because we do have that area right next to it that we can move into. But the problem there is that we need to retract it up at the top somewhere. What if we just did that, you know? Like, what if we just did... So, for example, we have our grabber, right? We have a grabber, right? No, that's not good either. We have a grabber. Now, on the side, we can have a hook. Using this hook, we can lock it into place. Right? You can lock it into place from the side. Now, it might not be a hook, but it might be more like just a tab sticking out. Lock it in from the side. No! Dumb. We can't have a tab sticking out because it needs to go into the bins. So we can't actually have a tab sticking out. But what we can have is a tab sticking out of the wall. It can be like that. Okay? And so it goes over to lock it into, to move it down. But then how does it lock into place? With the button mechanism I was talking about earlier. So like, it'll be like this, right? And this can just be at the very top. So if you go to here, the button mechanism can just be like over here somewhere, up at the top. So we don't need to worry about anything complicated. No, that doesn't work either. And the reason why the button thing doesn't work either is because when you pick up a card, it retracts it, and that would just trigger the button.
or that would trigger the click. And so you can't actually do that because it ruins the entire point of having the grabber be attached to the whatchamacallit. So we can't do that either. Okay. Now we need to think further. Think some more. Everybody. Come on, get those brains thinking. We need to cook something up. Let's see. I feel like if I were a more competent, designer, there would be a very clever solution to it. And everyone would look at it and be like, wow, that's such a clever solution to this problem. Like, with the H2D, the new 3D printer by Bamboo Labs, right? It moves one of the nozzles up and down while also having the thingy cover the other nozzle. This doesn't ooze, right? That's clever. And then it also has the cutter mechanism, and it just presses the thingy against the side, and that's clever, right? So I need to be clever. I need to be able to press something against a wall to lock it up into place, but not lock it up when it's not against the wall. So how do we do that? How do we lock it when it's against a wall and unlock it when it is not against this specific wall? Because we're maybe not against this wall, but it has to be like when it gets to the very top or something like that. Like we can have it unlock when we get to the very top, or like we can have it only lock when it goes to the very top and then goes against the wall. But when it's against the wall normally, it's fine. We can also do that. I don't know how that would work though. If you're tuning in right now, here, let me. Got a great idea. No, I don't have a great idea. Oh, right, I forgot I could do that. This might be better because you can see it bigger. So I need, let's see here. We have the ability to go extra up and extra to the side. So that gives you a very simple solution of just having a thingy on the wall stick out so that it retracts at the top, right? It can just retract at the top, and then it needs to go down. I would prefer to have it such that when it retracts here, you don't need to go up or do any silly complicated movements. You can just go down and then go over and then go back down. I want it to have this motion because that's fastest. Remember, speed is a little bit important. We don't want it to have to do any silly extra movements or whatever. So magnets. What if we did use magnets? Because what I can always do here, I've got an idea now. I can have this flexible, flexure or whatever. This thing can move left and right? So it can rotate around this axis. And so this part is like a clicky pen mechanism. But how about we have it be like so? So it's like a T.
right? This will make it very much preferred to be in this position, right? This is its normal resting position. This is exaggerated, right? Remember that. This design is exaggerated. And then it has a lock here or something. Or, you know, since this is 3D, it can be like this from this, right? Have a little peg. But basically, here it can have a magnet. And then on the wall where it has this to get it stuck in the upwards position, it also has a magnet. And let's say this is where that mechanism would go, right? So it moves up, and then these magnets repel each other. So then it gets locked. But then how do we unlock it? Well, when it goes up, it also, we can do just like the normal, go down and then go up. Then basically the L, this part, will be magnetized, or will go there due to the magnet, and then it can lock on like this to the piece that's normally here, right? Like it can be like this. So it can look something like this. And this is where it like latches onto on the part. Then when it gets clicked again at, let's say, the bottom, or yeah, at, let's say, the bottom of the entire doodad, then it will release itself, because using, well, how would it? Because it's not gonna just bite. It has to have springs of some sort. But we don't need the magnets. Because let's come up with a clever design. So we've got our idea of this, right? Our locking mechanism. There is our axis of rotation. And this, we'll say, is the part that latches on to a hook. This part. Right? So basically you can imagine those, you know, working harmoniously. So, what we can always do is have the magnets instead repel themselves here. So, we can have blue and blue, red, for example. And then, in the part where we actually want them to be together, here's what we do. We have the part that, you know, puts the bin up. It moves it upwards. Then this part will move down. But we can also have, I don't know. You can also have something. You can have anything. This is way too complicated. I don't need to do all this.
This is just a foolish solution to... This is just trying to be clever for the sake of being clever. This is not trying to be clever for the sake of solving a problem. Get rid of the magnet idea. Let's get rid of anything that has to do with springs. How would we do this purely mechanically? I have two axes of motion. I can go up and down, and I can go left and right. Maybe we do this. Oh, you know what? I got a great idea. Firefox. Here. This is to keep some of you entertained. All right. So, what are we to do? What are we to do? Gosh, maybe I should figure out a way to block Subway Surfers on my screen, because I'm just gonna watch Subway Surfers for an hour. Dang. Okay. Let's think. Because what we can do, we can just have a channel, and like, let's say the channel looks like this on the side, right? So when we're going left and right, we can just have it go into here, and then we can have it go down. But this path actually pulls a thingy. Like, we have it, this is the motion that our gantry moves in. Is just like this, and then this. But we can have this peg here, which can control something. Basically, we have a cam. You can make a cam profile, but straight. So, what does this mean? Here's what we can do. We can... Sorry, I'm getting a little bit distracted by the Subway Surfer. What I need is a way where I can control... I'm sorry, the Subway Surfers is getting me. Shoot, I hate Subway. Subway Surfers is ruining my mind. Okay, here we're gonna turn on Firefox overlay so that I can put Subway Surfers somewhere else. I do not need to see Subway Surfers, but you guys can see Subway Surfers. Let me get paint back. There it is. All right, that's better. Okay, enable paint too. Oh, okay. Can I grab paint, please? Thank you. There we are. And then I can move paint over here. It's not a problem, and I can cover Subway Surfers. Great. Okay. Let us think for a second. Let's say we took this motion. This is the motion we make with the gantry. And so in doing that, we can have this. This can be what moves our bin upwards in relation to, or not the bin, the bender in relation to the suction. Right? So it can be like that. That was horrendous. That was also horrendous. Why can I not draw a straight line? Like that, right? And then upon retracting, we have the ability to have a really simple way of locking it in place, which is basically... Actually, you know what's interesting is that we can't have any extrusions on our grabber, remember? So, meaning we need to do everything on a profile attached to the movement. I mean, attached to the the frame. So here's an idea of what we can do. Let's say, so this is from the side view of the picker upper. Like this is where our linear rail is, right? So we can have a profile of whatever here. But what if we simply had a thingy? So it would look something like this. No. It would look something like this. No. Look something like this. Yeah. And this is a circle. And then no, that's the axes of rotation. It'll look like that. And then here yeah, something like that. And then here on the inside section, we have this peg that goes through. Wait, I have this backwards. We actually are gonna have it go the other direction. So this is the axis of rotation. No. Whoa, there's an earthquake happening. Whoa, there's an earthquake happening, guys. Whoa, an earthquake. This one's a bit... Well, I'll be fine. Basically, we have this. And then this is the peg of the slidey bit. Right? Basically, we want to be able to stop this thingy. So this part goes down. And then we need a way to get this to go, you know, to the right. Here's the idea. This entire thing, like this has a cutout, right? For our mechanism. And what happens with our mechanism is on the side, we basically just have so how do you do this? Because remember, this is basically attached to them. So we need a way to move this up. We can go in this direction. We can go in this direction. So we can move like this. So the first part of the motion can simply be to move this downward. Right. And then how's that gonna work? Oh wait, I just figured it out. We have a second part to this here. It's like this. This part is actually the part that sticks out the most. Right. And then we have a profile that looks like this. Right. So basically, what we are doing is, so here, we're gonna do this again. This is
our, it's actually not that big. This is our grabber, right? Here we have a lever, something like this. That is where it rotates, and that's that. Here we have that in a little bit of a sliding area for, and that is attached to the suction cup. Right. So at the bottom, basically this will go all the way down. So it'll look like this. Right. Now, there's a peg here. And with, actually we don't need a peg, because this itself is a peg. We don't actually need a peg. But what we can do, now that we have this, is basically we move it into this like area. So I think we do need a peg actually, because it just makes it so much easier. Because then we only need to worry about the path of the peg and not the path of everything else. But basically the idea for the peg, and then there's also, well, we can just use the pin. No, we don't use the pin. We also need an indent like over here or something. This is a second peg. Yeah, this can be a second peg. But here's the idea. Basically, here is our profile. Our pegs can enter through that. Then we have an area basically between the size of the left and the right. Then this goes down for a distance. Meanwhile, this one stays in the same spot basically. Does it work like that? Can we do that? Oh, can we do that? I should definitely change the size of do that. The problem with me using such an old version of Microsoft Paint is that I only get 3 undos. So maybe this peg is not there. Maybe this peg is somewhere completely different. And we can have our cam profiles to be separate. We do that. But basically, we have a way to move this up the middle somewhere. Like it could even be something where it's just like that. It could really just be something simple as that. But basically, we have a way to move this up. And then, once it is up, we run this profile on that. What this does is it will move it into position and lock it into place. Now, to undo this is even easier, because all you need to do is bump this circle onto this face, and then it will unlock. This can go down. Now, is it a good idea to just bump it? Probably not. You probably just want to run it through this cam profile again, but in reverse, because that way it doesn't like suddenly like slam into the card, and that's bad. So there you go. That's entirely mechanical. Then you add a little bit of grease here so that it stays locked in place. It's like a lot of grease actually. You just like load this up with grease so that it doesn't move very easily. And then yeah, then once it's
in the vertical orientation, it should never move out of the vertical. Only when you want it to lock, when it will lock, and so it'll lock when you lock it, right? Now, what if it was even easier? What if we didn't need this at all? Here's another idea. Check this out. We've got thingy, right? Redraw a rule. In your rail, you know the deal. This is the peg that slides up and down in this hole. So don't actually need anything to rotate, I don't think. Well, okay, there's two ways we can do it. You can either have the thing rotate, or you can have the thing not rotate. I think it would be pretty simple if we had the thing not rotate, actually. Because, check this out. All you need to do, really, is, hold on, let me think. Maybe you do need the thing to rotate. Okay, here, I'll show you what I'm talking about. Basically, this is where our thingy is, right? This is our vertical attachment on. Looks something like this. And then it rotates around here. So what if you just had a peg here and a peg here, right? Then on the side, you simply just have a block, just one, right? You just have somewhere a block like that. And maybe not a block. Okay, it would look like this. Well, would it? Let me see. Because the issue is that we need to make this go up, right? This needs to go up. But when it's up, it can't, this is separate from everything else. What if we attach it to this? What if we attach to the part that moves to this part that also we guarantee is in a vertical spot, right? Because we know exactly where that is. We don't know exactly where this is. This is just a general idea. But how would we do that? I don't know. I don't know. It left a very large silence there, and even in that silence, it could not come up with a solution. I have a general idea of the solution right here. Like, with this pivoting mechanism and using the side profile as a way to manipulate it. Wait. I got it. I just figured it out. Oh, and it's so easy too. Is it? Oh, I did just figure it out. I know what, I got it. I figured it out. Now, the question is, can I do it in one simple motion, or does it have to be complicated, is the real question. I think it has to be. But how quickly can we do the complicated motion? Right, is the other question. Because, like, remember, we have to do this thousands and thousands of times. And so the faster we can do it, the better. So how fast can we get this complicated motion done? I don't know. And that's the problem. Well, in any case, let me show you the solution that I just thought of. Sorry, I got a mosquito bite like right on my ankle and it's really itchy. Because Taiwan's mosquitoes are horrendous. Ow. Ow. Itchy. It is so itchy, dude. Oh, it's so itchy. Ah. Dang it. Let's see here. Let's see here. So, let's see. What happens if, let's say, we... Because the motion that I need for this is basically like this. So you start like that, and then you go up a little bit, and then you go out. Right? But that means you need to, it's not like smooth, right? That's the problem. So, oh, the Subway Surfers are there to keep you guys entertained. It's not necessarily like for me. No, it's all for you. Subway Surfers are there so that you don't get bored, although I don't think that works. Alright, I'll see you later, MGX. Let's see. Because if I do this motion, it's cringe and bad. I would much prefer a motion that looks like but how do we do that is the question. Wait. I just thought of it. I think I figured it out. Yeah, I hit 3,000. Woo! Yay! That's crazy, isn't it? Yeah, 3,000. Big number. Yeah, maybe I will do like a 10,000 maybe a 5,000 celebration. I don't know what I'd do for that. I can give away, okay, I have one very special thing I can give away that's related to the channel. I can do a giveaway for the 3D printer glass plate used in the Bad Apple 3D printer. No. That's like my one really cool giveaway item, right? Everything else, kind of boring. But like, the really famous thing on this channel is that glass bed. So I could give away that glass bed. That I think is like, or maybe I just keep the glass bed. I don't know. It's something I have to think about because that's like the one notable piece of this channel history, right? But either way, I can't give it away right now because I don't have it. It's in Washington. So, alas. Okay, I think I know how to fix this problem of it being weird and cringe. So let's see here. Keep the glass bed? Yeah, I think so. think that is the play. Alright, here's how we are going to solve this problem. You have the grabber, like so. Then, on the linear rail side, you have this. Right, that is the peg that goes up and down. Then, here's what you do. Yeah, because problem is that you might have to do the cringe, the up and down. I don't want to do an up and down. I'm trying to avoid this motion pattern where it goes like that, then it goes up. That's what I'm trying to avoid. But it's looking more and more inevitable because that's again how you use a clicky pen, is you click it down and then you click it up. So if I'm going to do some similar mechanism, then it might have to be like this. So I think we're gonna do with that for now. We'll have the clicky pen mechanism. But how are we going to do the clicky pen mechanism, you might ask? We have another one here, like this. And then it will look like that. Goes up here. It rotates around this axis. And then this axis. And this is a peg. Now, this peg, what it does, this is the side profile. This is the cam. It looks like this. The cam is actually just this. The cam looks like this. Really not that common. Okay, maybe it's more like this, but either way, that is the cam. Side. Now, how might this work? First, this goes up, right? Or this peg goes into this cam. Then it goes up, which then moves this entire assembly up. Right. The entire assembly goes up. Then you can move the entire thing over to the right a little bit, which then would move this such that it locks it in place there. So like, it would look like this, right? And then you lift it up again and out. Then how do you undo it? You do it in reverse. You put it in, lift it up a little bit, or you push down a little bit. You move it to the other direction. You move the entire thing this way, and then you go back down, and it will release slowly. So there you go. It's actually very, very simple. Remarkably simple. So, I think it's time that we can implement this. Let me pause my Subway server. We're going to implement it here. On this side. Okay. We figured out the mechanism, so yay me there. I need to cut this belt, it is far too long. I need, like, I don't have like a really good set of angle cutters. Maybe I go buy something. Oh, I think the place is already. I have lineman pliers, but no, I don't have lineman pliers. I don't know. I have these things, but they don't cut it either. I tried to trust. Because I already had to cut this belt and it did not want to get cut. Ouch. The issue with it is that it has steel core wire, right? It's the steel cord belt, which makes it very tough. Yeah. So it's hard to cut through, believe it or not. So angle cutters, I just need to buy something. Let me cut it. If I try and cut it with my other tools, it just bends. And I think I eventually got it with I don't remember. You're also gonna head out? Okay, that sounds good. All right, let's see. Let's see here. It might also be time for me to head out too, because I think I might need a day to ruminate on this mechanism, how it's gonna work. Like, it's simple, but also like I want to make sure I get it right. So, yeah. So I think I will see you guys later too. It's been 3 hours and a half, so like we accomplished. What did we accomplish today, guys? We got this done. We put it onto the thingy. So now we can go left and right. We figured out the mechanism for lifting and lowering the grabber section, the bender of the grabber. And other than that, yeah, that's it. But I'd say that's fairly successful, considering before we did not have a plan at all. Now we have a plan, so we just need to put the plan in action, and we can do that tomorrow. Yeah, I might stream tomorrow, and then we can do it tomorrow. So maybe I'll wake up early tomorrow morning. Who knows? We'll see. So I'll see y'all later. Goodbye. See ya later. That's hidden, but I can click this button and now it's big. All right, see y'all later, everybody. Goodbye. Thank you for watching. Hit the dab like Wiz Khalifa or whatever. Yeah. Okay, bye-bye. 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 Bye. Bye. All right. Y'all later. Toodles.